Hello dear students, welcome back to BYJU'S Exam Prep. Now under data structures and algorithms, I was discussing about how to think recursively. Totally under this topic, I taken 6 subtopics, okay, and 2 of them are recurrence relations in 2 parts, recursive functions in 2 parts. Yesterday and day before yesterday I completed the recurrence relations part, and today I am going to start with recursive functions. Okay, so let us start with the recursive functions. Before that, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience, and my qualifications: M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. And these are all my areas of expertise: discrete mathematics, algorithms, engineering mathematics, C and data structures, theory of computation. From past 1 year, we are working on a project which is called GATE recorded content. It is first of its kind and unique content. We created visualized animated content from past 1 year. Under BYJU'S Exam Prep app, there is a category known as Learn with Video Lessons. There you can find these videos. I already recorded the following subjects: discrete mathematics, algorithms, engineering mathematics, C programming and data structures. Except theory of computation, all these subjects were recorded by me. And you can find all these subjects, that is recorded content, the unique visualized content, under BYJU'S Exam Prep app under the category Learn with Video Lessons. Okay, so this is about me. Now let us start with today's topic. Okay, dear friends, yesterday and day before yesterday I was talking about recurrence relation. That is how to express a problem in terms of subproblem. See, recursion means what, sir? Recursion is a process in which a problem is defined in terms of itself, but in smaller versions. Okay, so whether you call recurrence relation or recursion, the basic idea is problem in terms of subproblem. See, this is the main idea. Subproblem or one or more subproblems also. So you can say subproblems. That is the basic and main idea of recursion, my dear friends. And whenever you talk about recursion, there are 2 cases. One is called base case, or terminating condition, or stopping condition. Because when you write problem in terms of subproblem, the subproblem again can be written in terms of its subproblem. So this process will continue forever and ever and forever if you don't stop it. Therefore, we require this base case. Good evening, Tanmay. And recursion case means where we actually write problem in terms of subproblem. So under recurrence relations, I discussed this part, my dear friends. Okay. Now, this is an example for a recurrence relation. Okay. And I already explained this. Sum of first n natural numbers. You can write sum of first n natural numbers in terms of smaller version. That is sum of n minus 1 terms plus nth term. Actually, I given one more recurrence relation which is very, very interesting. Those who attended previous class, a function which calls itself is called recursion. That is called recursive function, Rajsekhar, my dear friend. Okay, a function which calls itself is called recursive function. And in that also, recursion is the process. Recursion is the generalized term. Am I clear? So in a relation, if recursion is used, you call it as recurrence relation. Okay. In a function, if recursion is used, you call it as recursive function. That is a generalized term, my dear friends. Ravali K, very good evening. Very good evening. Okay. Right. So in first class, I explained this. Sum of first n natural numbers. That is under recurrence relation part 1, I explained this. How can you write sum of first n natural numbers? You can also express it like this. 1 for n is equal to 1, and when n is greater than 1 and n is even. See, recurrence relation does not mean that nth term in terms of n minus 1, sir. Nth term in terms of one or more previous terms. Okay. So this is also a recurrence relation or recursion. Here also recursion is happening. Problem expressed in terms of smaller versions of itself. So it is a recursion. Am I clear? Now look here. I also explained this. 2 into sum n by 2. Okay, I need some space. Plus n by 2 whole square. This is when n is greater than 1 and n is even. And what about when n is greater than 1 and n is odd? In this particular case, we also seen this 2 into sum n minus 1 by 2 plus n plus 1 by 2 whole square. So this is also recurrence formula, my dear friends. That is, sum of n terms can be expressed like this. Here also we expressed sum in terms of previous terms, or nth term is expressed in terms of n minus 1 term. Here also nth term is expressed in terms of half. Am I clear? Half of the term. Half here because n should be even. See, when n is even you can take half, but when n is odd we should take integer value we should get. Actually natural number value, therefore I take an n minus 1 by 2. In that terms we express this. I already explained this, my dear friends. Am I clear? In the previous videos. Now the main aim of this, that is today's lecture and tomorrow's lecture, is about recursive functions. We talk about recursive functions, and this is one of the important topic for GATE point of view, and you can see many questions were asked on this topic in GATE examination. Okay, so let me explain this process of recursive function, that is how recursive function can be evaluated. Generally in GATE examination they give you a recursive function or recursive formula and they ask what is the output of this particular code with this particular input. Okay, so that is the functional value with a particular input. What is the answer they'll ask you, where the function is calling itself. So what is recursive function, sir? Recursive function is a function which call itself. A function which call itself is called recursive function, and the process is recursion. The process involved is recursion. Even if you want to find or write recursive function, we should have a recurrence relation. See, mathematically that relation is called recurrence relation. Here we call it as recursive function. See, the process is recursion. Whatever you call it, the process, the main process is called recursion, where problem expressed in terms of same problem. The smaller versions of same problem is recursion. Am I clear? Anyone having doubts, sir? Wonderful. So let us continue. All recursive functions works in two phases. Okay, there are two phases under which these recursive functions works. The first one is called winding phase and the second one is called unwinding phase. See, in winding phase what happens? The function keeps calling itself. The function keeps on calling itself. That is what we call it as winding phase. Okay, so this phase terminates when it sees a base condition or stopping condition. See, if you don't keep base condition, what happens? It keep on calling itself and it may get into an infinite loop, my dear friends. Am I clear? So if you don't keep base condition or base case means what? Stopping condition. Once the stopping condition become true, the winding phase stops. Then comes this unwinding phase, my dear friends. In unwinding phase, what happens? All the recursive calls start returning in the reverse order to the previous calls. And what happens? Ultimately, you reach your first call, my dear friends. Am I clear? And in this phase, the control returns through each instance of the recursive call. Okay. Now we try to understand this with examples. Okay. That is about the story, winding phase and unwinding phase. Simple terms, winding phase means where the function call itself. In unwinding phase, what happens? The function call returns. The function call returns happens. Okay. So now let us see example, my dear friends. This is a very famous example. You all know it. If anyone solving it, please try to answer this. What is the answer for this problem, my dear friends? Rajshekhar, Ravali or anyone can try this. See, my dear friend, this part which I am explaining is very, very important. Okay. See, there are two ways of solving it. If you know what is that recurrence relation or what is that recursive function is doing, directly you can give the answer. Otherwise, we should see how the winding phase happens and how the unwinding phase happens to tell the answer. Today, we'll try to take a very basic example. Tomorrow, we try to extend this idea for some more complex variations. Am I clear? So that is the basic idea. And once you understand this idea, you can happily answer any question which is asked in GATE examination, my dear friends. Am I clear? That's it. So let us solve this problem. Now here I want the value of fact 4. See, you all know this. This is a factorial function. And what is factorial? You write this now, n factorial. What is n factorial? The product of first n natural numbers. It actually goes like n into n minus 1 into n minus 2 into and so on up to 3 into 2 into 1. So this is your factorial. So if I use this fact for representing it, factorial of n, see what is happening. If you see this up to here, it is factorial of n minus 1, that is multiplied with n. So it is n into factorial n minus 1. See, this is your recurrence relation. And the same recurrence relation is used to write this recursive function. But you have to incorporate the base conditions. And for factorial, because factorial is also defined for 0, otherwise for 1, factorial is 1. That we know it. But for factorial, 0 is defined as, this is the definition of factorial 0, sir. 0 factorial is 1. So in our recursive function, we should also incorporate this. Am I clear? So that's why you see when n is 0 or n is 1, we are returning 1. We are returning what? 1. Otherwise, what we are returning, sir? N into factorial n minus 1. Now let us see the winding and unwinding phase clearly, sir. Please try to understand this process. This process is very, very important whenever you want to see any recursive function like this and you want to know the answer. Of course, this is a factorial 4. We all know the answer is 4 factorial is 24. But I want you to understand the process, because the same idea can be used for very, very complex problems also. Okay? See, we don't directly start with complex problems, sir. We take very simple problem to understand the process properly. Once you understand the process, any complex variation. See, here we have only one function calling itself. Sometimes you may be calling, the same function may be calling multiple functions with multiple parameters. So we need to understand that also. Especially when you see dynamic programming, the recursion happens with multiple parameters. CNR or matrix A in multiplication, if you see, okay, it is called with 2 parameters. Okay, so you can understand all those ideas properly if you understand this carefully. Okay, so let us start with this, my dear friends. What actually happening? I am calling this particular function with what input? Input value is 4. So factorial 4 we called. Now factorial 4, because n value is not 0 and 1, it will call this part. Means it reaches this part. And this value is written. What is written, sir? N value. N means what? 4 into fact 3 value should be written. But unless or until you know the fact 3 value, you cannot return the value. So here we are in turn calling fact 3. That is fact 4 is calling fact 3. Now fact 3 will do what, sir? Because n is not 0 and not 1, what happens? It will call n into, that is, n here is 3 into fact 2. N minus 1. 3 minus 1 is 2. Now what fact 2 will do? Because it is not 0, not 1, it will call what? N. N means here 2. N value is 2. 2 into fact 1. 2 minus 1 is 1. Now you see n value is 1. So what fact 1 will do, my dear friends? Fact 1 will return, because when it is n is 0 or 1, it returns the value 1. So this fact 1 will return. See this part, so far whatever we done, this is what we call it as winding phase. What is this? This process up to this callings, what we call it as winding phase. In winding phase, function keeps on calling itself with smaller inputs. Am I clear? Depending on the recursive formula. Is the idea clear? Now starts our unwinding phase. See, winding phase moves in this direction from top to bottom. That is, function calls itself with smaller parameter. Again it calls itself with smaller parameter. Again it calls itself with smaller parameter. Now comes your unwinding phase. What is it? Unwinding phase. In unwinding phase, what happens? the function called returns. Means fact 1. Now here it is not calling because you reached the base condition. This is your base condition. The base condition or terminating condition is reached. So fact 1 will return the value. What value it returns? It returns 1. So let us use different color for this. It returns the value 1. So fact 1 returns 1. But the process is not completed. After getting this value, it has to be multiplied with 2. 2 into 1. What is it? 2. And that is returned. So here the value returned is n into fact n minus 1. So here value returned is 2 into fact 1 is returned. So this value is returned. So 2 into 1 means how much, sir? 2. That is returned. So fact 2 value means 2 is returned. Now 3 into what? 3 into 2. That is 6 is returned. Now 4 into 6. What is 4 into 6? 24 is written. Suppose in the main function, if you are printing the value of fact 4, the value which is printed is 24. So what is the answer for fact 4, sir? 24 is the answer. And this is the simple process of, finding the value of a function or recursive function for a particular input. For this, we need to understand winding phase and unwinding phase, my dear friends. But if you know what is this function directly, you can skip this process and directly, suppose if you understand it is factorial, and you know factorial 4 means what? You can directly write the answer 4 into 3 into 2 into 1. Means if this function is exactly behaving as factorial n, you can directly write the answer, my dear friend, without doing this winding and unwinding phase. But you may not identify all recursive functions perfectly. One should always know this winding and unwinding phase, my dear friends. Hope you understand. Is the idea clear? If you are having any doubts, please do ask me. Can anyone give answer for this, my dear friends? The next problem. Can anyone try this? What is the answer for this? Yesterday or day before yesterday, I given this recurrence relation. Now for the same recurrence relation, we have written a recursive function. Am I clear? See, sometimes the recursive code may be given in a particular programming language. Obviously in GATE, in C language it will be given. Otherwise they may give you recursive algorithm. Means this may be given like this also. An algorithm may be given like this. Okay? If n is 1, return 1. Otherwise return n plus sum n minus 1. See, when it is a algorithm, the syntax is not taken care, my dear friends. Because pseudocode means what, sir? It is a mixture of natural language and some programming constructs. Am I clear? So sometimes the same story may be given as a algorithm. It is not restricted to your C programming language, my dear friends. Here the code which I given is in terms of C programming language. Good evening, Harveer Singh. Yeah. Is the idea clear? So that is the idea, my dear friends. So that is about algorithm. Okay. Now let us see what is the output for this particular program. Can anyone answer this? What is the answer for this? Okay. See here, of course, because it is sum of first n natural numbers and you are calling with input, we know the answer. But I want you to understand this winding and unwinding phase properly with simple examples. Once you understand, always try to understand any concept with basic examples. If you learn the concept with simple examples, you can understand the details. See, some people directly want to attack very, very complex problems. Without understanding details, if you attack those problems, it will attack you. Okay? So you may get heart attack. Please be careful. Right? Now let us take this problem, my dear friends. Sum 5. So in this, what happens when n is 1, it returns 1. Otherwise, what happens? It will return. Because 5 is not 1, what happens? The second part, that is return part will happen. That is return n plus sum n minus 1. That is, it will call 5 plus sum 4 is called. That is, sum 5 is internally calling sum 4. Now sum 4 will call what, sir? 4 plus sum 3. And this will call what? 3 plus sum 2. And this will call what? 2 plus sum 1. And this is your winding phase. Sum 1 means we reached n is equal to 1. We reached n is equal to 1. Means what? The unwinding phase starts. Now sum 1 returns what value, sir? Sum 1 returns 1. Sum 1 returns 1. Now please tell me what is 2 plus 1? Oh, very difficult question. You can use calculator also. Right? What is 2 plus 1? 3. So it will return what? 3. Now 3 plus sum 2 value 3, no? 3 plus 3, what is returned? 6. Now 4 plus 6, 10 is returned. And finally, what happens? 10 plus 5, 15 is returned. Is the idea clear? Suppose if you already know what this particular function is going to do, you don't have to do this winding and unwinding phase, my dear friend. Directly you can find sum 5. See, that is the advantage of knowing what this function is doing. Okay? So for that, we need to have the idea of recurrence relations. Am I clear? Recursive formulas also you can call. There is nothing wrong. See, mathematically it can be called as recurrence relation or recursive formulation. No problem. There are different terminologies, my dear friends, used in different places. So people use different terminologies for that. That's it. Hope you understand. So sum 5 directly, if you know it is doing sum of first 5 natural numbers, you can directly do 5 plus 4 plus 3 plus 2 plus 1. Am I clear? So what is the answer? 15. Directly you can say the answer for this, my dear friends. Okay. Very good. Next problem. Two ways. You can use winding and unwinding phase and give the answer, or directly, if you observe, you can give the answer for this. What is the answer for this? What is the answer for this? Gate question. Oh, gate is not written, so some people feel bad. It's a gate question. See, sometimes they'll give you this fun, for fun, or short version of function. What is the answer for this? Is it exactly same as our previous problem, or any changes? Is it exactly same as our previous problem, or any changes? No change. You observe no change. Very good. Fine. See, my dear friends, in the previous problem, what is happening? Sum is equal to, sum n is equal to n plus sum n minus 1. Here also same thing is happening now. Instead of n, we use x here. X plus fun x minus 1. But the story variation is here. The base condition. See, we are stopping at 0, sir. We are stopping at 0, not at 1. In the previous case, we are stopping at 1. And when n is equal to 1, if you see this, when n is equal to 1, it returns 1. So at n is equal to 1, it stops. But here, for n is, or x here actually, x is equal to 1, it does not stop. For x is equal to 0, it stops. And for x is equal to 0, it is returning 1. Means we are getting sum of first n natural numbers plus 1 extra. If you observe, the answer is directly 16, you can write. If you don't observe, you may do, some people, you know, observe it and they feel, okay, it is sum of first 5 natural numbers, they'll go for this answer. In GATE, such small twists will happen. There is a twist in the story. It's like, you know, suspense movie. Am I clear? And at the end, you know, the suspense is revealed. So you have to be careful whenever you are reading the recursion or recurrence relation or recursive formulation from this recursive function, my dear friends. Please be careful. Am I clear? Now if you observe this, okay, if you see same fun 5 calling what, sir? 5 plus fun 4. And this is calling what, sir? 4 plus fun 3. And this is calling what? 3 plus fun 2. This is calling what? 2 plus fun 1. Now it is not stopping here. Fun 1, for n is x is equal to 1, it is not stopping. It will call x is equal to 0 also. That is, it will call 1 plus what? Fun 0. What is fun 0? Now the unwinding phase starts. Fun 0 is what? Not 0, it is 1. Fun 0 is 1. So 1 is written. 1 plus 1 is how much, sir? 2. 2 plus 2, 4. 4 plus 3, 7. 7 plus 4, 11. 11 plus 5, 16. Or if you observe this, it is sum of first n natural numbers plus 1. Directly you can give the answer for this, my dear friends. So this is what we call it as observation. See, this observation you can improve if you can write recurrence relations on your own. And that is what exactly I started with in the previous 2 sessions, my dear friends. Okay. See, I am not starting from, somewhere at the middle. I am starting from the beginning. The beginning of the story is recurrence relations or recursive formulation. One should always start from there. How to write problem in terms of subproblem. See, this story, winding phase, unwinding phase, you can always use, sir. That is not a big deal. Okay. If you practice little bit, you can easily solve these problems. There is nothing. Am I clear? But if you can able to observe that, you can quickly answer that. And you also know the proper problem solving strategy. And the same stories are used throughout your algorithms. Let it be divide and conquer recurrence relations or divide and conquer algorithm techniques or dynamic programming technique. In all these, the basic or the main idea is expressing problem in terms of subproblem. Please remember that. Okay. Next one. Can anyone answer this question, sir? थोड़ा complex लग रहा है. Can anyone try this? See, some people feel that, I give very simple problems. So let us take one good problem like this now. Anyone can answer this? Okay. So people are giving chance to me. Thank you. Now let us see this. See, my dear friends, suppose if you know that it is an alternative way of writing sum of first n natural numbers in terms of half. Half means when n is even, this is what happens. Otherwise, that is when n is odd, this is happens. This is what happens. In the beginning of today's lecture, I explained the same thing. I given this particular formula if you remember. The sum of first n natural number, the other way of writing this is, for n is equal to 1, it is 1. For n greater than 1 and n is even, it is 2 into sum n by 2 plus n by 2 whole square. This is when n is greater than 1 and n is even. And 2 into sum n minus 1 by 2 plus n plus 1 by 2 whole square when n is greater than 1 and n is odd, my dear friends. Okay. Hopefully I am not covering myself. Yeah, fine. It's fine. Is the idea clear? Right. So if you understand this, we are actually asking sum of first 5 natural numbers only. So the answer is 15. But if you don't understand that, if you don't know this particular formulation, obviously we have to go for winding and unwinding phase. So let us see this. Let us see this, my dear friends. So let us call this with sum 5. We just follow. See, if n is equal to 1, return 1. Otherwise, n greater than 1. That is when n is greater than 1 and even. This will happen. Otherwise means when n is odd, this will happen. And that is exactly the formulation which we discussed earlier. Now let us see sum 5. Now 5 is greater than 1 and it is odd. Odd means this particular formulation will happen. That is, you are going to, means what is the answer for this? 2 into sum 5 minus 1 by 2. That is 5 minus 1 means 4 by 2. That is 2. Sum 2 is called plus n plus 1. N is 5. 5 plus 1 is what, sir? 6. 6 by 2 means 3. 3 square. This is what happens. Or if you want exactly, you can write like this also, sir. There is nothing wrong. Now what happens? This sum 2, because again we are having function call. So function call will happen. that is function call itself. So sum 2 means what? Because 2 is even. Even means this if part will happen or else part will happen. Even means if part will happen, yeah, else part will happen. Even means if part, yeah, else part. Okay, Rajit Jain, CS 91, very good evening, sir. Very good evening. Ritik Jain, sorry. Ritik Jain, sorry. If part, yeah, else part. When you start the class, sir, in BYJU'S Exam Prep officially? Mr. Ritik Jain, my classes officially started in BYJU'S Exam Prep. Presently, they are in recorded mode. From past 1 year, I am associated with BYJU'S. We recorded the content for GATE, recorded content. It is a first of its kind unique content, visualized animated content. Under BYJU'S Exam Prep app, learn with video lessons, you will find these videos. Those who purchased can get the entire course. Those who want to see, go through those videos, they can get, okay, some of the videos, my dear friends. Right. Very good. Now, sum 2, can anyone answer? Okay. Sum 2 means what? 2 is even. So, this if part will happen, not else part. So, 2 into sum 2 by 2, that is sum 1 plus 2 by 2 into 2 by 2. 2 by 2 means 1 into 1 or 1 square will happen. Now, sum 1, when n is equal to 1, directly return will happen. So, now the unwinding phase starts, my dear friends. Sum 1 will return 1. So, 2 into 1 is 2 plus 1, 3 is returned. Now, 2 into 3, 6 plus 9, 15 is returned. Got it? And you got the answer. And those who know this idea, like sum of first n natural numbers can also be represented like this, you can answer without doing this winding and unwinding phase, my dear friends. See, that is the advantage of knowing recurrence relation. See, for every problem you may not understand what exactly it is doing, but for majority of the problem you can understand this, what exactly is happening. If you start from recurrence relations. See, most of the people ignore discrete mathematics, okay? But not just discrete mathematics, these concepts we also study in your algorithm course also. Actually, if you see any of your good algorithm books, they start from recurrences only. Okay, after time complexity discussion, they start with the basic idea of recurrences only. Am I clear? So that is the best way to start. Am I clear? Wonderful. Now let us see what is the output for this problem, sir. So we already answered this question, right? 15 is the answer. Very good. Now what about the answer for this problem? What is the answer for this problem? Anyone want to answer this? Is it a very difficult topic which I am dealing with, or a very basic level problems I am doing? So tomorrow we do not have class. Again, my class is on Monday. Okay. So there is a slight change in the schedule. Instead of Sunday, Monday, Tuesday and Wednesday will continue the same story. Monday I come up with this recursive functions part 2, where we take up some more interesting problems. Okay, we try to handle how we can go with this this winding and unwinding phase. When you have more than one function calls also, we'll try to discuss that. Okay, tomorrow day after tomorrow, that is on Monday, I'll come up with recursive functions part 2. And on Tuesday, binary tree traversal techniques. Together with shortcuts, even the idea of recursion I'll discuss. Generally that is ignored, so that part I want to discuss on Tuesday. And on Wednesday, the most important, very famous dynamic programming based problem, that is matrix chain multiplication, will be discussed on Wednesday. That is on 1st June. Please note that. Okay. Now let us see print 5. Print 5 will give you what option? Output. Okay. See, I are not given options, sir. Just I want to go through this recursive calls. So first we start with print 5, sir. I think it is small p, no? So let me write small p. Print 5. Here also there is a printing mistake. It should be small p. Okay. So capital P, if you call, if it is a programming language, it will tell you, sorry, what is this? Okay. So print 5. Print 5, what it is doing, sir? See, when n is equal to 0, it just simply return 0. Means it will not do anything, just will return back. Nothing is done. Return back. Return 0 means nothing is done, just return back. Am I clear? Now here, print n minus 1. See here, else part, that is if n is not 0, that is n is greater than 0, what is happening? We are printing n minus 1. We are printing or we are calling n minus 1. Print n minus 1. There is a small, doubt, piece of doubt for most of the student here. Am I printing n minus 1 value or I am just calling it? See here, under this else part, there are two works to be done. You have to be very careful. There are two works to be done. Every time there are two works. In previous problem, the single work, n into function call. But here, the calling of the function, that is print n minus 1, that is print 4 is happened. There is one more work. What is the one more work? Printing of the value. But this printing of the value, directly I am writing this printing of the value means 5. See, when I write 5, please understand that it is printed. The value is printed. So the print n value is printed. But this n value is printed in the return process, because after this work is completed, because first is this work, followed by that this printing of that value is happening. Please remember that. Now what happens? Print 4 again will do two works. What are the two works? It will call print 3 and it will print 4. After print 3 calling, that is winding and unwinding phase completes, then this will happen. Some people write it like this. Instead of like this they write it. Means you complete this, then you do this. Your wish, sir. Okay. Whatever way you understand, you can draw the diagram, my dear friends. Okay. Now print 3 will do what, sir? It will call print 2 and it will do one more work. What? It will print 3. After print 2 work is completed. See, this work happens in the return phase. So some people, what they do is in return phase they write the values. But generally why I do like this is, in this recursive call, what are the activities which are happening? And first activity happening is this. After this, this will happen. So that I will show you in the unwinding phase. The printing, how it will happen. That output I will show you in the unwinding phase. These are the two activities which are to be done under this recursive call. Now under this recursive call, print 1 is the activity. After this activity is completed, there is one more activity, that is printing the value of 2. Now when again print 1, what it will do? It will call print 0 and this one printing will happen. One printing will happen after this. Now print 0 will return what, sir? It will return 0. So now the unwinding phase starts. Unwinding phase starts. So print 0, it will return 0. And the return value you are not using anywhere. If you see the previous example, the returned value is multiplied or added with some of other values. But here return 0, that 0 we are not using anywhere. Just return 0. Are you using that value anywhere? Nowhere we are using. So that 0 just return to that particular function. Now what happens after that? There is one more activity, because this activity is completed. What is the other activity which is remaining? Printing activity is remaining. So that is done now. One is printed. And here there is a backslash t means what, sir? Backslash t means tab. Backslash n means new line. That is about C language, my dear friends. Am I clear? Format specifications we call it. Now after printing 1, so now output 1 is printed. You go back here. Means the activity of this function, that is print 1 function activity is completely complete. That is print 1 will do these two activities. The two activities are completed and you are simply returning back. returning to this particular function. That is called function is print1, you return there. Now print1 activity is completed. Now in this there is one more activity. What is it? Printing of 2. With a backslash t means tab 2 will be printed. Now after this you return here. Just return. Okay. That return value we are not doing anything, sir. Just return. Means this activity is completed. One more activity is left. What is it? Printing of 3. Do that activity. 3 is printed and you return here. Now this activity is completed. What is one more activity remaining? 4 to be printed. That is printed and you go here. This activity is completed. One more activity is left, that is printing of 5. 5 is printed and you go back here. Now the activity of print 5 is completed. So this is the story, sir. See, in a recursive function call, sometimes there may be multiple activities. So you should understand what are the activities are happening, in what order those activities are happening. Recursive call is happening. Together with recursive call, there is one more activity which is happening. That is printing of that number. So first recursive call is done. After this recursive work is completed, the printing activity is done. Because of that, the numbers are printed in the reverse order. What if I reverse these two? इन दोनों को अगर मैंने reverse कर दिया तो क्या होगा? Let us see that. Hope you understand the output of this. This is the output for this, my dear friends. Again, here small printing mistake. It should be small piece. Please remember. Now here, first I am printing the character or value. Then I am calling the print function. Okay. So here, first you call print 5. Print 5 because n is 0, it will return 0. Otherwise, what it will do? It will do this activity, else part. In else part, totally 3 activities are there. First activity is printing that printf, means that number is printed. Second activity is calling the recursive function. After recursive function call returns, it will return the value. So total 2 activities. Okay, this is return activity means you can say that is third activity. That we can show with the arrow mark, my dear friends. That is unbinding phase arrow mark, we can show it. So the 2 activities are, first is printing of the number. That is first number is printed. That is output. First we will get 5. Followed by the second activity is what? What is the second activity? You are calling print function with n-1 argument. That is 4 argument. After that, return value, return is there. That happens when this part is completed. Now print 4 will do what, sir? It will first print this number. That is first number is printed. Okay, here I not use backslash t, so the numbers may be printed next to each other. In previous example, I used backslash t, but here backslash t is removed. Nah? So that is, format specification. No backslash t means all the numbers are printed adjacent to each other. Okay. 4, after that, print 3 is called. Now what happens? 3 is printed. Now print 2 will happen. Now what happens? 2 is printed. Then print 1 is called. Then 1 is printed. So after 3, 2 is printed. See, printed means directly you have to write the output. Then 1 is printed. Now 1 is printed, then print 0 is called. Now print 0 will return what, sir? Because with n is equal to 0, it returns 0. So now the return process started. So, okay, color we changed here. So you can write like this. 0 is returned. And after this value is returned, that value we are not doing anything, sir. The returned value we are not doing anything. Simply we are returning back to its called function. Okay. Now this we just return to here. And here also the complete activity is completed. So we move to the parent. Here also the complete activity is completed. You move to the parent. Now again move to the parent. Again move to the parent. And here the numbers are printed in the reverse order. Whereas here the numbers are printed 1 to 5 in the correct order. See, if you want print the numbers in the correct order, because we are starting from 5 now, correct order means the printing should happen at the end. That is last in first out manner it should happen. Whereas here first in first out manner it should happen means what? We are doing it like this. Am I clear? See, generally in your binary tree traversal also, we use like there are 3 types of traversal, right? In order, pre-order and post-order. So here it's like pre-order. The previous one is like post order. First you complete call, then you print, like that. Am I clear? So that is the logic which we need to understand. Hope you understand. Anyone having doubt, please do ask me, sir. Please ask me. Yeah, yesterday someone asked me this question. Using tree method we can solve it. So I just taken the same example for you, my dear friends, with tree method or the recursive call method. How can you do it? That is winding and unwinding phase. How can you solve it? Let us see this. Now here we are calling, if you know that it is a Fibonacci series means it starts with Fibo 0 is 0, Fibo 1 is 1, and Fibonacci series means what? You just add the previous two numbers to get the next number. 0 plus 1 is what? 1. 1 plus 1, 2. 2 plus 1 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. 21 plus 13 is 34. So this is what we call it as the famous Fibonacci series or sequence. Am I clear? And this is Fib 0, this is Fib 1, Fib 2, Fib 3, 4, 5, 6, 7. So the answer for this problem is 13 if you understand this is a Fibonacci series or Fibonacci sequence. Directly 13 is the answer. If you do not know, then you have to go with this winding and unwinding phase, my dear friends. Hope you understand. So let us see. We call Fib 7. Now here, if x is less than or equal to 1, 1 is written. That is x value means less than or equal to 1 means x value is written. X means if x is 1, 1 is written. X is 0, 0 is written. Am I clear? Of course, when you write such code, you have to be very careful. You are calling it with only non-negative integers. Am I clear? Please be careful. Sometimes some people write like, if x is equal to 1, return 1. If x is equal to 0, return 0. Separately they write it. They don't want unnecessary trouble there. Am I clear? Because some people may do some mischiefs like they call it with some negative number. So don't do like that. Okay? Of course, even if negative number is called, that is written, but Fibonacci sequence only works for non-negative integers. We should take care of that. Okay. Now let us see Fib 7. Fib 7 means what? See here, there are two function calls. Okay. There are two function calls. One is with Fib. Okay. One is with, okay, you can show it like this. Two function calls. Now one is with Fib 7 minus 1, that is 6. And the other one is with Fib 7 minus 2, that is 5. But what is the return value after calling these two? See, this function value is written and this function value after returning, the sum is returned to Fib 7. The sum is returned to Fib 7. Now again here Fib 6, what happens, sir? Fib 6 will call what? Fib 6 will call Fib 5 and Fib what? 4. And this will call what, sir? Fib 4 and Fib 3. You get a big tree, my dear friends. Every time the sum is returned. Now here Fib 4 and Fib 3. And actually if you observe, so many values are repeated. And because of that, instead of recomputing it, we can store the values and reuse it. And that is exactly dynamic programming uses. Dynamic programming means the tabulation method. So what they do, they just tabulate these values. That is whatever value is calculated. See here Fib 4 is calculated. Again, why to calculate Fib 4? So instead of recomputing it, you can store and reuse it. That is what dynamic programming uses. Dynamic programming is also recursion only, but you store the values and reuse it. Of course, when you talk about dynamic programming, you can discuss that, sir. Am I clear? Now look here. Fib 4 will do what, sir? It will call Fib 3 and Fib 2. See, if you write the complete story, it would be little dangerous. Fib 2 and Fib 1. Now Fib 3 is Fib 2 plus Fib 1. Am I clear? Now Fib 2 is, oh here I don't have space, I'll just write it here. Okay, I'll just make some space for myself. Fib 2 plus Fib 1. I thought of giving Fib 5, sir, but unfortunately for previous problem 7 I taken, this also I taken 7. No problem, we can do it, sir, it's not a big deal. Fib 1. So this is Fib 1 and Fib 0. And this Fib 1 directly, see Fib 1 is what? 1, Fib 0 is 0. 1 plus 0 means 1 is written. Here what is the value which is written, sir? Here value written is 1. And this 1 plus is Fib 1 is 1. 1 plus 1 means 2 is written here. So the fifth3 value is 2 and fifth2 value already you calculated now 1. So I am just directly using it instead of drawing that. 2 plus 1 is 3, so that 3 value is written here. Now fifth2 value, because I already calculated fifth2, no, 1 and fifth1 is 1. So 1 plus 1, 2 is written here. Now here 3 plus 2, 5 is written here. Now fifth4, because I already calculated fifth4, no, fifth4 is 3, right? So 5 plus 3, 8 is written here. Now here fifth4, because I already calculated fifth4, I am not doing it again. That is exactly what you do under dynamic programming. Okay, so that logic I am using here. And fifth3 somewhere we calculated 2. So 3 plus 2, 5 is written. Now 8 plus 5, 13 is written here. And the answer for this is 13. See, if you know it is a Fibonacci sequence, directly you can write that. Otherwise, you can use this process, my dear friends. See, this process is not difficult. We just need to understand what are the activities happening under the recursive call. That you need to keep track. If you can keep track, using this winding and unbinding phase, any problem can be solved just like this. Is the idea clear? So we can take some more problems tomorrow. Tomorrow in the sense, next class. Okay. So this is a homework for you. Please try this. And today is 28. So again 30th, we'll do this recursive functions part 2. On 31st, binary tree traversals. So I'll give you the shortcut for this, and also how by just looking at a tree, you can write in order, pre-order and post-order traversal, how you can do that. That also we'll discuss. That is the unique method, sir. So let us try that also on 31st. It's a very important for your GATE point of view. And on 1st June, I'll be coming up with this important topic, that is matrix chain multiplication. See, I'll discuss the recurrence relation, how recurrence relation is formed and how you use to solve the problem. There are some simple tricks we can use to solve the problem very quickly. That I'll discuss on 1st June, my dear friends, and all these classes starts at 8 p.m. Okay? So with these topics, I'll be concluding this story, how to think recursively. Okay? So I'll stop here. If you have any doubts, my dear friends, please do ask me. These are the 3 topics. And if you can go through these 6 topics, 2 to 6 marks you can expect in GATE examination. Because in GATE examination, based on these topics, almost 6 marks questions were asked. Am I clear? Indirectly, it may go beyond that. Because if you understand recursion, the entire dynamic programming is ready. Entire divide and conquer algorithms are ready. So many stories can be made simple, sir, if you understand the recursion idea. One need to develop the idea of recursion. How to think recursion or recursively. How to formulate the recursive functions or how to write recurrence relations. One definitely need to understand if you want to score good marks in algorithms. Because algorithms, 60% of the syllabus is based on recursion. Am I clear? So, Shasha, okay, please follow the classes. If you have any doubts, please do write in the chat, or otherwise after the class also you can write in the comment sessions, my dear friends. Please give your feedback. Okay, whether you like it or you don't like it, please let me know. Am I clear? Because it will help to improve, to reach you in a better way, my dear friends. Am I clear? So I want your feedback always. Please do make comments. See, if it is bad, you can say that, no issues. Please try to follow the classes. It would be very, very useful for your GATE exam. Whatever topic I'm coming up with, they are definitely useful. I am starting from basics, my dear friends. See, dynamic programming, generally people feel very, very difficult. That also we'll attack. That also we directly take that problem. That is on 1st June, we solve that problem. Even binary tree traversal, there are shortcuts. And without using shortcut, but directly by looking at a tree, how we can write the different type of traversals also we can discuss. If you want to do all that, we need to understand recursive thinking. And that is the main aim of this topic, my dear friends. So with this, I'll stop today's class. If you have any doubt or comment, please give me for last 2 minutes. That's all for today. Thank you. Last 2 minutes, waiting for your comments, sir. Okay. So that's all for today, my dear friends. Thank you. On Monday, that is on 30th, we'll continue with some more very, very interesting problems, which concludes your recursive function idea. With that, you can handle any problem in your gate. Okay. That's all for today. Thank you.